we need to start looking at anti-differentiation of trig functions. Now, going back to differentiation, if I'm looking at a function of sine x, then you do remember that the derivative of sine x with respect to x is cos of x. So cos of x is the derivative of sine of x. So for the function cos of x, sine of x will be its antiderivative. Okay, which means that the antiderivative of cos of x with respect to x is sine of x plus c. I won't forget that. Now, if I look at the derivative with respect to x of cos of x, then derivative of cos was negative sine of x. So what will be the antiderivative of sine of x dx? Well, it cannot be just cos of x plus c, because derivative of cos gives me a negative sign, which means that antiderivative of sine of x is negative cos of x. What were our other functions that we needed to look at differentiation or use it often? Well, obviously we looked at derivative with respect to x of a function tan of x, and we used the table of derivatives for it, and we had that derivative of tan was sec square of x, which means that the antiderivative of sec square of x dx is tan of x plus c. So we are using actually the definition of differentiation to get to antiderivative. So let's look at the last one. What about derivative with respect to x of sec of x? What's derivative of sec of x? Remember, in your books on the page 86, you've got a table of derivatives. I will be referring to a similar table just now, but you can check it. What's the derivative of sec of x? Derivative of sec of x is sec x times tan of x, which means that the antiderivative of sec x times tan of x dx will be equal to sec x plus c. Okay, pause it, think about it. In this first video, we're going to look at simple examples of integration with the trig functions. So similarly to differentiation of trig functions, in order to anti-differentiate trig functions, we need to look at the table of derivatives. Since we are integrating, we're going to call this a table of antiderivatives. On the page 131 in your textbooks, you have a table of antiderivative. So we had a table of derivatives on the page 86, and now we have a table with antiderivatives. Remember, what's the most important when you will do your calculations with integration of trig functions? The most important is that this table is right in front of you. You cannot anti-differentiate trig functions if you are not looking at that table. Believe me, it will be too confusing. So how can I use this table? Just to repeat some examples from the previous slide. If I'm looking for the integral of sine x dx, then the integral of sine of x, its antiderivative, will be negative cos x plus c. If I would like to determine the antiderivative of, let's say, cosec x times cot x dx, what will this antiderivative be? Well, here is a minus. I don't have a minus on my integral here. Therefore, the integral of cosec cot will be negative cosec x plus c. In a similar way, if I want to determine the antiderivative of cosec square of x dx, this will be negative cot of x plus c. Okay, boys, please pay attention. It is not the same as an algebraic function to the power of 2 when you think about 1 up. Not here. If the function appears in your table of antiderivatives, you use it as is. That's a very important theory of antidifferentiation. We are looking at exercise 7.3 on a page 130. Question number 1, GHIJ. Those ones are your basic applications of integration with trig functions, where you should just be using table of antiderivatives and do everything by inspection. Right, so let's look at the first example. You have to determine the integral of cos of a specific angle with respect to x. Now the integral of cos of 2x from the table is sine of that angle plus c. Now we are almost there. Almost, because you remember that if you were to reverse the process and you would like to differentiate this function to get back to your function cos of 2x, you will have an inner derivative that stays, which means that we need to have 1 over 2 sine of 2x plus c in order for this entire function to give us a derivative of cos of 2x. Okay, hope it makes sense. Try the next one. Integral of sine of any angle is negative cos of that angle plus c. Okay, from table of derivatives, have the table in front of you, at your nose. Is that all? Well, if I just think about inspection, and I can write it on the side for myself. If I want to differentiate cos of 3x minus 1, okay, with a minus in front, what do I get? Derivative of cos is minus sine, so minus and a minus will simplify to a sine of 3x minus 1, but I will have to have times 3 as an inner derivative. Since I do not have 3 here, then I need to get rid of this 3 by introducing the coefficient of 1 over 3 to my answer. Make sense? I hope so. Pose it, think about it. The next one. There is a sec square of a function under it. It is very easy to confuse it with algebraic problem with a bracket square. That if under the integral I have a bracket square, then I will try with a bracket 1 up. Well, you must be careful. It doesn't work that way with your trig functions. The first and the most important thing is to check if there is a sec square of any angle in the table of antiderivative. So my question is, Do you see sec squared on the table of your antiderivative? Your answer should be yes, I see sec squared, which is then antiderivative of tan of that angle, right? Plus c. Again, is that all? Obviously not, because I'm integrating with respect to t, so reversing this process, I will end up with minus 1 over 3 as a factor. Sorry, minus 3 times sec squared. So what do I need in front of this function? I need minus 1 over 3. Is that all? Well, in this example, no, boys, because pi is our 180, so we will be required to use reduction formula to simplify it to the end. So we will get 1 over 3 with a minus, pi minus, that's my second quadrant in which 10 is negative. So this minus will simplify, and then I've got 10 of 3t plus c. You can reduce it already under an integral. You can reduce it at the very end. The most important part is you do not have the same approach as to your algebraic function. You have to have the same approach as you had to all other examples with the trig functions. What's the approach? Look at the table of antiderivative. Let's look at the last example. I have antiderivative of cosec of 4 theta and cot of 4 theta. Multiplication cosec cot of exactly the same angle. Does this appear in your table of derivatives? The answer here is yes, it does. It will be equal to a minus cosec of that angle, right? Because there is a minus in a table of derivative. Even if I add c, obviously my problem is the same as in all the other examples. I will have an inner derivative, therefore it becomes minus 1 over 4 cosec 4 theta plus c. Please stop it, reverse it, look at the 4 examples, see if you can get correct solution.